Okay, this is lesson 2.3, and it's called Kids Just Want to Have Fun. In this lesson, we are going to determine the constant of proportionality, and we are going to solve problems using the proportional relationships between two variables. And that is stated here in our learning goals. The key term for this little investigation is constant of proportionality. So you'll need to update that in your orange vocabulary. Many organizations and businesses rely on market research and survey results to develop new products. For example, the music industry relies on survey chart listings to determine how well an artist's songs are selling and being played on radio stations. The higher the level on the album charts, the more the record company will try to get the songs used in television programs, movies, or even commercials. Even the movie industry relies on surveys to determine which movie trailers should be shown at the beginning of certain movies. They also review weekly attendance reports on attendance reports a movie generates and how much money a movie generates through box office ticket sales. The greater the money amount, the more showings of the movie will air in theaters. Well, this makes sense. Just something for you to think about. Can you think of other industries that routinely use survey results and market research for decision making of products? Well, there are a ton that do. Problem 1, top of the charts. Magic Music, a company that produces new recordings for an artist, determines that 4 out of 5 girls will like the new recording artist Sally Powell. If 4,000 girls were surveyed, how many liked Sally Powell? Explain how you determine your answer. This little guy gives us a great idea. Scale up a ratio or use proportion to determine the value of a ratio you're scaling up. So in this, we would annotate and say that 4 out of 5 girls will like the new recording artist Sally Powell. So 4 out of 5, that's our ratio. And then for our question, it asks about if 4,000 girls were surveyed. Well, this is girls, and this is total. If that's the case, we need to figure out where would 4,000 girls surveyed total go. Should it go in the numerator or denominator? I'm going to give you a second to think about it and then come back in and see if you got it right. So you should have placed 4,000 in the denominator because it is a total. And then we're going to place our x in the numerator because that's our unknown. That's what we need to find out. So you can use different strategies for this. A lot of you like to use cross multiplication where I say 4 times 4,000 because these are the two that we have. And then we divide by 5 to find out what x is. Or you can simply scale up and say, well, 5 times some number is 4,000. I need to take 4 and multiply by that same number. I am just going to use cross multiplication to figure this out. So I have 5 times x and then 4 times 4,000. Then I'm going to determine what 4 times 4,000 is, and that is 16,000. And that's what 5x equals. Then you simply divide by 5 on both sides. Remember this from solving equations. And if I divide 16,000 by 5, I get 3,200. So my x up here, if 4,000 girls are surveyed, 3,200 would like the actual artist. In this next problem, we have 300 girls that liked Sally Powell, and they want to know how many were in the group total. So in this situation, we're going to use that same 4 over 5, okay, because this is a total. This is girls. Then it tells us that 300 girls like Sally Powell, so 300 has to go on the top because that's how many girls liked on both the numerators, and then we don't know this x here. So from there, I want you to go ahead and try to solve for x, and then I'm just going to post what the x equals for you to check your answer. Give you a second to check your answer, and then we're going to move on. So on number 3, we're going to complete the table to show the number of girls who like Sally Powell and the total number of girls. So we've already done this one, and we determined that it was 3,200. We also already did this one, and that was 375 total. I want you to calculate these three using proportions and scaling up or cross multiplication to determine these answers. Then come back in and check your answers to see if they're correct. So hopefully you determined that this is 150 total. You need to show your work on the outside somewhere. This is 960 total, and this is 310 total. The next part says determine the ratio between the number of girls who like Sally Powell and the total number of girls for each row in your table. Write the ratio in simplest form. So over here, we're just going to simplify these ratios, and I'm going to write them in fraction form because they are part to whole. So this one is 4/5. We don't need to simplify it. It's already simplified. If we take 3,200 over 4,000 and we scale it down, that also simplifies. If we drop these zeros, we're actually looking at 32 over 40, which if you simplify that, so if I took these zeros off, then that's actually 32 over 40, which 8 goes into both of those. 8 goes into 32 4 times, and 8 goes into 40 5 times. So that one simplifies to 4/5. I want you to go down the row and write the ratios out and then simplify them down into simplest form, and then come back and check your answer. So as you can see, I've simplified these over here. I hope you got the same answers. It says, what do you notice about the ratios? Well, the ratios are all the same. In a proportional relationship, the ratio between two variables is always the same or constant if they're proportional. This ratio is called the constant of proportionality. Generally, you can use the variable k to represent the constant of proportionality. So, what is the constant of proportionality for k, the ratio between the number of girls who like Sally Powell and the total number of girls? So, in this case, the constant of proportionality is four-fifths. Problem 2 is called girls' sports. Vista Middle School has determined that 5 out of 7 girls play sports at the school. The constant of proportionality k is 5/7, or 5/7. Write an equation showing the relationship between the number of girls who play sports S and the total number of girls T in the constant of proportionality. Well, since our constant of proportionality is 5/7, that's going to equal S over T, which represents the girls who play sports and then the total number of girls. Because it was a total number of girls, T, that's why the total went on the bottom, because that's where totals go in part to whole ratios. So the way that we solve this is just like we did with the others. You're going to cross multiply. So we're doing this number again. So you're going to have 5 times T equaling 7 times S, because all we did was multiply our means and extremes. So 5T equals 7S. And from your last unit, you should know in order to solve for T, you're going to have to divide. So if we want T by itself, we're just going to divide by 5 on both sides. And T equals 7 over 5S. If you're a little bit confused on that, it's okay, because I don't think you'll have anything this difficult on K-Prep. Let's go ahead and move to number 2. It gets a little easier. So we're going to use the equation to solve, which is 5/7 equaling our S represents the girls that play sports. and then the total number is on the bottom. And this gives us, if 75 girls play sports, sorry, 175, how many total girls are there? So we don't know the T, but we do know that 175 girls play. So now, again, we can use cross multiplication, or we can scale this up to figure out how many total kids are there. So I want you to give a second, go ahead and try to solve for this, and then come back and see if you're right. Give you a second to go ahead and check your answer, and then we're going to move on to B. There are 287 girls, which is a total. How many play sports? So you need to take a second, write out your proportion, and go ahead and solve it. Then you want to come back and make sure you did it correctly. And check yourself. We're going to move on. I'm going to go ahead and assume that you're understanding how to do this. I want you to, if you need to check your answers, you just need to find me and we can get the answer key book for you to check for this page. We're going to go ahead and move to problem 3, which is, what does the constant of proportionality represent? So there are 4 girls for every 3 boys enrolled in Sherman Middle School, which is a part-to-part ratio. You're going to set up proportions for each question, then solve each proportion to determine the unknown value. Use the information from the ratio given. So if there are 15 boys enrolled in the school, how many girls are enrolled in the school? So I'm going to give you a second to try to set up a proportion and then solve it for the unknown value. And then I want you to go ahead and check your answer. So as you can see, we have, this is the proportion and the way it's set up. The reason I chose to put 15 down in the denominator is because they're both boys. So you can use the scale up method and say 3 times 5 is 15, so 4 times 5 is 20, and x is 20. So that tells me there are 20 girls. I'm going to let you go ahead and try out B and then come back and check. All right, so hopefully you got those right. The next problem asks us to define the variables for quantities that are changing in this situation. Well, the 2 quantities that have changed in A and B are boys. So let's use B for boys. And that's like the number of boys. And then G is number of girls. Set up a proportion using the variables for the quantities to the ratio given for enrollment of girls to boys at Sherman Middle School. So what that means is we are going to use the numbers that were given to us in the problem, and then we are going to cross multiply again. So we have G here and we have B here for what we set up. So when we cross multiply, we are going to end up with 4B equaling 3G. And then if we are trying to get, oh, it actually doesn't tell us to solve here. So go ahead and go to the next page. And then now it asks us to solve. So we have 4 over 3. I'm going to rewrite this quickly. And then we have G for girls over boys. Okay, so then when you cross multiply, we're going to have 4B equaling 3G. And then when we solve for G, we have to divide by the coefficient, which is 3. So this now gives us G equals 4/3 D. So what is the constant of proportionality in this equation? Well, the constant of proportionality is your coefficient here of 4 over 3. What does the constant of proportionality represent in this problem situation? Well, 4 over 3 can be turned into a mixed number, which is 1 1/3, which means that it represents for every girl there are 1 1/3 boys. The next problem asks us to kind of flip that, and it says write an equation for the number of boys enrolled in Sherman Middle School to the number of girls. So that means instead of having G by itself up here, we're actually going to solve and get B by itself down here. You still start with the same equation. So we have G over B. You cross, which you normally do. We're going to have 4B equaling 3G. This time we are going to divide by the coefficient in front of B, which is 4. And then you're going to have 3 over 4 G equaling B. This represents for every, well, let's go to the next page and write that down. So what do you notice about the constant proportionality in each situation? Well, if you looked at it, hold on. I flipped back on you guys because I didn't see that we didn't write these down. So the constant of proportionality in the situation, again, is 3 over 4. And then what does the constant of proportionality represent in the problem situation? It represents that for every boy, there are 3/4 girls. I know it doesn't make sense to have like 3/4 of a girl and 1 1/3 of a boy, or 1 1 1/3 boys. But in this problem situation, that is actually what it's representing. Now moving on, what do you notice about the constant of proportionality in each situation? Well, it was 4 over 3 for girls and 3 over 4 for boys. So I'm hoping you think in your mind it is the reciprocal. So the constant of proportionality are reciprocals of each other. So the next question, do you think each constant of proportionality makes sense in terms of the problem situation? This is kind of what I was talking about earlier, that it doesn't make sense to have a part of a person. So this is where you would say, no, it doesn't make sense. The constants of proportionality each represent a fraction or a mixed number of people, and that's strange because we only have whole people. So you're going to want to write that down in that section for that problem. So sometimes the constant of proportionality is not a whole number. The constant of proportionality can also be a decimal or a fraction. When the constant of proportionality involves whole items like people, it may seem strange to think about the constant of proportionality in terms of a fraction. Instead, you can think of the constant of proportionality as a way to predict outcomes of a situation. So that's kind of what I meant earlier. So use the given ratio about boys and girls enrolled in Sherman Middle School. If there are 79 boys enrolled, use the constant of proportionality to determine how many girls are enrolled in the school. I'm going to kind of let you go with this and finish up this last problem. You don't have to go any further in the book than this for right now. So I need you to just complete these problems and check your answers and then move on to 2.5.